Okay, this is moles, an introduction to moles, which is on pages 10 to 13 in your textbook. Okay, so what is a mole? So we're going to use an analogy first. So if you have lots of 1p piece coins, you've got lots of pennies, maybe you've got 100 pennies you've been saving up, and you go, okay, 100 pennies is £1. 100 pennies is £1. So I'm going to take my 100 pennies to the bank in order to get £1. And you put the pennies into one of those bags that they use at the bank. Take it to the bank. And what does the cashier do? Does the cashier count every single one of your pennies and says, yes, you've got 100 pennies, you can have £1? Or does the cashier do something else? So the cashier will weigh the whole bag of coins. And the cashier knows that 356 grams of pennies is equal to £1 and is equal to 100 pennies. And if your bag weighs 356 grams, then you can have your pound. And this is exactly the same with atoms in chemistry. Atoms are so small that we don't count the atoms. Instead, we have something called a mole. 1 mole, which is the amount of substance. We'll do the definitions in a moment. 1 mole is just an amount of substance. And 1 mole is the same as 12 grams of carbon. 1 mole is the same as 12 grams of carbon. That is the relative atomic mass of carbon. Relative atomic mass of carbon. And you can get that off the periodic table. The symbol we use for relative atomic mass is a capital A and a small r. That's the relative atomic mass of carbon. In grams is 1 mole. And that is equivalent, that's the same as 6.02 times 10 to the 23 atoms. Okay, and this is something called Avogadro constant, the Avogadro constant. Just be careful with your spelling here. Avogadro constant. And this is something that's been developed by an Italian called Amedeo Avogadro many, many years ago, where he calculated the number of atoms in a mole. And so this is the way we work it out. We say 1 mole is the relative atomic mass in grams, and it's equivalent, the same as 6.02 times 10 to the 23 atoms. So for example, if we take sulfur, and I go, okay, I wonder what 1 mole of sulfur, I'm sorry, my handwriting, sulfur. I wonder what 1 mole of sulfur, I wonder what that is equivalent to. Well, 1 mole of sulfur, if you look at on the periodic table and look up the relative atomic mass of sulfur, you'll see that sulfur is 32.1 grams, 32.1. And therefore the relative atomic mass, 32.1 grams of sulfur is 1 mole, which is the same as 6.02 times 10 to the 23 atoms of sulfur. And you could do this with any element on the periodic table. If we take copper, the relative atomic mass of copper is 63.5. So if I take 63.5 grams of copper, then that is the same as 1 mole. I wonder how many copper atoms are in there. There's exactly the same number. 23 atoms of copper. And this is what 1 mole is. Now this value, this Avogadro constant, you don't need to learn it, you don't need to remember it, because it's on your data sheet. If you look on the back of your data sheet, will have the Avogadro constant. Okay, so what if I haven't got 12 grams of carbon? Maybe I've only got 6 grams of carbon. Okay, I've only got 6 grams of carbon, so how many moles of carbon have I got? Then I have got half a mole of carbon. I wonder how many carbon atoms are there? There are half of this amount of carbon atoms, so that'll be 3.01 times 10 to the 23 carbon atoms. Okay, so just the relative atomic mass in grams is 1 mole. Right, and this isn't just for elements on the periodic table. It can also be for molecules as well. So if you take, for example, if you take water, the formula for water is H2O. And what is 1 mole of water? Okay, so now it's a molecule. This is not an element anymore, it's a molecule. So we need to take the relative molecular mass, and that is, for water, is 18, because hydrogen, the relative atomic mass of hydrogen is 1, and there's 2 of them, and oxygen is 16, the relative atomic mass, so that adds up to 18. This is called the relative molecular mass because it's a molecule. Relative molecular mass because it's a molecule. And the symbol for that we use is Mr, capital M, little r. And that in grams is 1 mole. How many water molecules are there? Because it's 1 mole, there are 6.02 times 10 to the 23 molecules. Carbon dioxide, if we have molecules of carbon dioxide, what is the mass of 1 mole of carbon dioxide? You have to work out the relative molecular mass. Carbon is 12, oxygen is 16, and there's 2 of them. This is the relative I'm using here. This is the relative atomic mass I'm using here from the periodic table. So when you add that up, that comes to 44. So 44 grams of carbon dioxide is 1 mole. How many molecules of carbon dioxide is that? It'll be exactly the same, Avogadro constant, 10 to 23 molecules. Okay, now just remember what this times 10 to the 23 means. So if you have 6.02 times 10 to the 23, this means that the decimal place moves 1, 2, 3, 4, 5, 6, 7, etc. That many places, up to 23. So that is a very, very big number. That's the number of molecules that's in 1 mole of carbon dioxide. So this can be applied to atoms, to molecules, and to ions as well. Okay, and that is Avogadro's constant. Now the actual definition of a mole, you do need to know the definition of a mole, and it can be asked in an exam. It can be asked, yeah. So let's just write down the definition of a mole because it can be asked in an exam. So this is the definition. A mole is the amount of substance. The amount of substance containing as many particles as there are carbon atoms in exactly 12 grams of carbon 12 isotope. You'll be doing isotopes at some point as well. So everything is compared to carbon 12. So a mole is the amount of substance containing as many particles as there are carbon atoms in exactly 12 grams of carbon 12. Okay, so the thing to remember is the relative atomic mass in grams is 1 mole. The relative molecular mass, if it's a molecule, in grams is 1 mole. Okay, we need to know one other thing here. So we need to know as well about molar mass. What is molar mass? Molar mass. Now, molar mass is the mass per mole of a substance. So if I was to ask you the question, I could say, okay, what is the molar mass of water? What is the molar mass of water? Then it's the mass of 1 mole of substance. So we already know that the relative molecular mass is 18 for water, 16 and 2. So it's the mass for every mole, per mole. Okay, do you know in maths when something is so for example, if you have 10 to the power of -1 in maths, what does that mean? 10 to the power of -1, it means 1 over 10. So when we've got the term in chemistry mole to the -1, it means 1 over mole. 1 over mole. Okay, if we have the term 1 over in maths 10 to the -1, what does that actually work out as? Will you try that on your calculator? What does that work out as? 1 over 10 will actually come out as 10. And so similarly in chemistry, 1 over a mole to the -1 will come out as mole to, just come out as mole. So 1 over mole to the -1 will just come out as mole. Okay, you can just try that on your calculator, 1 over 10 to the -1. So if it's on the top, it becomes on the bottom. If it's at the bottom, it moves to the top. If it's on the top, it moves to the bottom. If it's on the bottom, it moves to the top. Okay, so an equation that's going to help a lot when we're doing calculations, an equation that's going to help a lot is this equation here. Moles equals mass over molar mass. And we're going to do a lot of calculations in chemistry, a lot of moles calculations, because when you're doing a chemical reaction, you need to know how much starting material to use, you need to know how much product you're going to make, so you have to do calculations before you start an experiment. Now if we put the units in here, the units of mass are grams, the units of molar mass are grams per mole. Sorry, I forgot to say that mole is just a shorthand for moles. It's just what we use for shorthand for moles. So molar mass is grams per mole, and you can see on the top and the bottom you can cancel out the grams on the top and the bottom, so you're left with 1 over mole to the -1, and then 1 over mole -1 is just mole. So moles equals moles. So that works out, moles equals moles. Okay, right. So something else in the notes you have to make notes on for next week is about types of formula. Okay, types of formula. So first we're going to take one type of formula. Okay, so this is called types of formula. Types of formula. And remember, formulae is the plural and formula is singular. Okay, so the first type of formula is molecular formula. Molecular formula. And you need to know the definition for molecular formula. So molecular formula is the actual molecular formula is the actual number of atoms, the actual number of atoms of each element So writing's not very good. Each element in a molecule. Molecular formula is the actual number of atoms of each element in a molecule. So for example, we take this molecule here. Okay, do you know what that's called? That's called hydrogen peroxide. Okay, hydrogen peroxide. Hydrogen peroxide. And that tells us that there are 2 atoms of hydrogen, 2 atoms of oxygen in this molecule. It's the actual number of atoms of each element in a molecule. Okay, if we take this formula here, which is actually benzene, it's the chemical name, this tells us that there are 6 atoms of carbon, 6 atoms of hydrogen in this molecule. So it's really useful. Molecular formula is very, very useful. And there's something called empirical formula. Empirical formula. Empirical formula. So be careful with your spelling here. Empirical formula is the simplest whole number ratio, the simplest whole number ratio of atoms of each element present in a compound. Okay, so empirical formula is the simplest whole number ratio of atoms of each element present in a compound. So let's take this hydrogen peroxide here. Okay, that's the molecular formula. But what will be the empirical formula? What will be the simplest whole number ratio? So it's 2 to 2. So the empirical formula will just be HO. Because we take the 2 and the 2, take it down to its simplest whole number ratio, and it'll just be 1 to 1. Ho, 1 to 1. What about this? We take this down to its simplest whole number ratio. It will just be CH. For every 1 carbon atom, there's 1 hydrogen atom. Okay, what about this one? What about if we take C2H6? It's a molecular formula. C2H6, that's ethane. What's the empirical formula going to be for C2H6? It's just going to be CH3, because the ratio is 2 to 6. The simplest ratio is 1 to 3. Okay, so that's empirical formula and molecular formula. And you need to know how to be able to work this out. Okay, so if we have a question that says, for example, we have a question that says we have got 1.08 grams of a compound, okay, and the compound contains oh sorry, no, the question, let's just change that question. Not 1.08 grams of a compound, so I'm just going to change that question. If we have 1.08 grams of carbon, in a compound, okay, and we have 0.09 grams of hydrogen in a compound, and the relative molecular mass is 78. What is the molecular formula of the compound? What is the molecular formula? Okay, so that's the question. So we've got 1.08 grams of carbon, 0.09 grams of hydrogen. We've got the relative molecular mass. What is the molecular formula? And the method we use, we call the empirical formula method. The method we use is you make columns. If you use this method, you will have no problem. And we're finding the ratio between carbon and hydrogen. And the first thing you do is you write the mass underneath each element. And then you divide by the relative atomic mass. So carbon is 12, hydrogen is 1, divide by the relative atomic mass. What are you basically doing here? You're doing a mass over relative atomic mass. You're basically finding the moles. Mass over molar mass for a molecule's relative atomic mass for elements. And you do that calculation. Okay, now this one's quite easy. I can do this one in my head. There we go, 0.09. But what does that calculation come out as? 1.08 over 12 also comes out at 0.09. Okay? And then this is a simpler example, but the next step is to divide by the smallest number. Divide through by the smallest number. And the smallest number is 0.09. 0.09, and that gives you a ratio of 1 to 1. And this tells us that the empirical formula is 1 carbon, 1 hydrogen. That is the simplest whole number ratio. But the question said, what is the molecular formula? And we know that the MR is 78. So the way you work this out is you go, okay, I'm going to add up carbon and hydrogen. That gives me 13. The relative atomic mass 12, and the relative atomic mass 1, and that gives me 13. I know that the total relative molecular mass of this compound is 78. So therefore, I'm going to go, how many 13s are there in 78? And there are, when you do that calculation, there are 6 13s in 78. So I know that there are 6 lots of CH in this molecule, in this compound. So therefore, I know that the molecular formula must be C6H6, because there are 6 lots of C and 6 lots of H. Okay, you can do this calculation just the same if you don't have grams. These are grams. If you don't have grams, if you have percent instead, that's okay. You do exactly the same thing. For example, let me just give you an example. If you do it with percent, so if I was to say, get clean piece of paper, if I was to say that there's a compound and it contains sodium and oxygen, those are the 2 elements it contains, and I have got 74.19%, this is a percent, of sodium and 25.81% of oxygen, so that's got to add up to 100. You treat it, what is the empirical formula? I'm just going to write EF, empirical formula, what is it? You treat it exactly the same, okay? You divide by the relative atomic mass, which is 23 for sodium, 16 for oxygen. You divide, you get the answers, okay, which is 1.613 on this side and 3.226 on this side. You divide by the smallest number, so divide by, that's the smallest number, and that comes out as 1, 2, 2. And therefore, the empirical formula of this compound is going to be sodium oxide. 2 sodiums, 1 is the empirical formula. So if you have a percent, it's okay to do it exactly the same. Okay.